Okay, so today we have the definite integral from 0 to pi over 2 of cos x sine x dx. Now, whenever we have an integral by U-substitution, we're going to want to look at the problem area. Now, what do I mean by that? Well, notice that sine of sine x could have just been sine x, but we have another trig function as the angle. So to me, that seems like a problem. So hence, that's going to be our problem area. Okay? So when I find my problem area, I'm going to want to take my problem area and set it equal to u. Okay? Now this means that I can sub in u for sine x. But now notice that I have dx and not du. This means with respect to x. So I can't really integrate this part. Okay? So let's take the derivative of this. So doing that, we have du by dx is going to give me, and taking the derivative of sine x, it's just cos x. Okay? Now notice that we have a dx, and I want to get this dx alone, because if I can get dx alone, then I can sub this in and have it in terms of u. So this is going to be the same thing as du is equal to cos x dx, but I don't want du, I want dx. So dividing both sides by cos x, we get that dx is going to be equal to du all over cos x. Okay. Now the next thing we're going to want to do after finding u and finding dx is calculating our new upper and lower bounds. So let's look at sine x equals u. Now our upper and lower bounds represent x values in our question, because our variable is within terms of x. So I can say, well, when x equals 0, this implies that u is going to be equal to sine of 0. Okay, and what did I do? I subbed in 0 for x. And also, when x is pi by 2, then this implies that u is going to be equal to sine of pi by 2. Now evaluating these, we have our sine x graph to the right, so we can see that this coordinate is going to be 0, 0. That's just going to be 0. And at sine of pi by 2, we can see that the height of our graph is 1, so hence this is going to be 1. Okay. Now putting everything together, our new integral is going to look something like this. So it's going to go from 0 to 1. Cos x is still going to stay the same. Sine, now we said that sine x equals u, so we can sub that in. Okay. Now look at this. If we have dx, well, we can't really take the integral of sine u because it's with respect to x, and that's why we solved for dx. So now subbing in dx, we get, well, dx is the same thing as saying du divided by cos x. Okay. Now notice that this is basically saying, well, I have 1 over cos x multiplied by du. That's the exact same. Okay, because if I multiply by du, then I take it to the numerator. So we can rewrite this integral as the integral going from 0 to 1 of cos x. Now if I have to rewrite this, I'm gonna put that next to this so it's more easier to see, and then sine is gonna stay the same, sine u, and this is gonna be du. Now if I multiply these two together, this is gonna cancel. Okay, so that's why we rewrote it that way. And if those cancel, this is going to be the integral from 0 to 1 of sine u du, which is much more easier to integrate. So now taking the integral of sine u with respect to u, let's think about the antiderivative. Okay, so if I have minus cos u and I take the derivative, well, let's ignore the minus sign for a second. So the derivative of cos is going to give me minus sign. Now if I look at my minus sign and then take the derivative, I'm going to get sine u. So hence the antiderivative of minus cos, or well, sine, is going to be minus cos. Okay, once again, because that might have been confusing, what I did was take the derivative of minus cos, and because that gives me sine, well, we can say that this is an antiderivative. Okay, if this gave me something else, like let's say this gave me tangent, then this is not an antiderivative. Okay, because it gave me this, that means it's an antiderivative. Okay, now evaluating this is going to be minus cos of 1, which is the upper bound, minus the lower bound, which is going to be minus cos of 0. Let's take a quick look at the graph of cos. It goes 1, 0, minus 1, and then keeps going. So we know that at 0 the height is 1, hence here we're gonna have minus 1. And notice how we can't really evaluate this without a calculator, because cos of 1 degree is what? 1 degree is like somewhere there, and that's just impossible. It's probably like 0.999 or something of that sort. Okay, so this is going to be minus cos 1 degree plus 1, and then we can rewrite this. If this looks weird, we can say this is just 1 minus cos of 1. Now with this answer we can conclude that the integral from 0 to pi by 2 of cos x sine into sine x with respect to x is going to be equal to 1 minus cos of 1 degree. And you can put this in your calculator to get the exact value, but this is the final answer.